Alright, hello everyone. I hope you're still good and still doing well. So today we'll be dealing about chapter 8, which is about chemical nomenclature. Okay. So before I go any further, I'm going to try to keep this as short as possible, not as fast as possible because I speak very fast. So if I try to read very, very fast than I speak, you literally not gonna hear what I'm saying. Okay. So basically, this chapter is about it refers to naming of the compounds and writing their names. Okay. So we're looking into writing formulas, writing names, and also oxidation numbers. That is finding the oxidation numbers of unknown elements. Right. So now, if you look under the section of writing formulas and writing names, you will see there we have those that are written in red, we have those written in blue and those written in purple. Same applies here, right? So basically, for example, for number one, we'll be looking into binary compounds and writing the binary, the formula for binary compounds between two nonmetals, and also writing the name of binary compounds between two nonmetals. Same applies to number two and number three, okay? And now with the names, okay, we need to know what do we call our names. Now, the name has to be unique, or we can use a common name. Now, how do we go about this? We do this by following the IUPAC rule. So basically, it just states that here now, the more positive portion should be written first, and the negative portion is written last. Okay, or you can just look into this that element with a less electronegativity is more positive, therefore it comes first, and that with more electronegativity value is negative, or has a negative oxidation number. Okay. And then now, coming to binary compounds between two nonmetals. Still on that, okay? So basically, with binary compounds between two nonmetals, what you need to look into is that you need to know your Greek prefixes. When you come to binary compounds between two nonmetals, you need to know your Greek prefixes. This is very simple from your mono, di, tri, penta, hexa, hepta, octa, nona, deca, that you need to know. And also, very important, do know that for mono, you do not use mono for the first element. Do not use it. Do not use mono for the first element. Say now, if you, for example, you have CO2, you don't say mono carbon dioxide. No, it's carbon dioxide. Okay, you do not say mono for the first element. You can use that for the second element, it's fine, but not for the first element. And also, you need to know that it ends with IDE, like your oxide, sulfide, hydroxide, and so forth and so forth. Okay, and then now the number of atoms are stated by their Greek prefixes. Can you see here, like pentachloride? The number of the the number of the atoms are stated by the Greek prefixes. These Greek prefixes. Okay, I will do another clip that focuses on examples. All right, now between binary compounds between a metal and non-metal with a fixed oxidation number. Okay, guys, before going any further again, please do know your metals. Do know what are your metals. Do know what are your non-metals. Study your periodic table. Please, you need to know them. You need to know what are your metals, and you also need to know which one are your non-metals. Okay, please do study that. Do study your periodic tables. Now, okay. So with this one, we take oxidation number into account. Now, what is an oxidation number? An oxidation number is a positive or a negative number that expresses the combining capacity of an element in a particular compound. Okay, that is so important. Is the positive or negative number that expresses the combining capacity of an element in a particular compound. It can be positive or negative depending on whether the element tends to attract electrons strongly or give them up. Right, so now element with a low electronegativity values has a more positive oxidation number, and that with a high electronegativity will have a negative oxidation number. Do keep that in mind. Also, it also ends with IDE, and in this case, we do not use the Greek prefixes. We take oxidation number into account. So these also, you need to know that everything that's in group 1, the oxidation number is positive 1. In group 2 is that 3. In group 4 it's plus or minus 4, but most of the time, like Dr. Kotze said, it's positive 4, right? And then and so forth. Group 5 is minus 3. Group 6, the oxidation number is that 7, and group 8, those are the normal gases, so it's 0. Okay, now I'll also do another clip that focuses on these examples. Okay, this is just a quick theory. Now, finding oxidation number for unknown elements. Okay, now every compound must be neutral. If oxidation number of one ion is known, then the other can be determined. And I'll also do an example on that. And binary compounds between metal and non-metal, variable oxidation number. Again, it also ends with "ide." Now we use Roman numerals, like when you have copper 1 and copper 2 there, right? And then the last one is the binary compounds with atomic ions. Now, what is a polyatomic ion? Is a charged group of covalently bonded atoms, like your nitride and your sulfides. Now, also the name here, it's different from those ones. It doesn't end with IDE, but it ends with "ite" or "ate", like sulfite, sulfate, okay? And also there are no Greek prefixes, and here also take oxidation number into account. Now I'll just gonna give you guys another video that focuses on examples.